Hello everyone, welcome to Maths Kitchen. I'm James. This is Homework Club week number 4. Maths Kitchen is the Facebook page here as well as my YouTube channel, and everything I do on the YouTube and on the Facebook here is to help you with your maths. And every Sunday, usually at 5 o'clock, is it 3 o'clock this week? Usually at 5 o'clock I do this Homework Club where if you are struggling with any piece of homework, just let me know. The more specific you can be, the better, and I'll go through it and do my best to help you. And you can let me know live. You can type in the chat, and I will help you on the spot if I can. Right, on today's agenda, and so I've had 2 people ask me from on my YouTube channel for a bit of help. The first one was some general help with a bit of SATS preparation. How can I get ready for my SATS exam? This is year 6 SATS. So I'll start off with that, and then the second thing that I was asked to look at, I think it was Mariam, if I remember rightly, was to look at solving simultaneous equations. So I'll go through, I'll do the SATS stuff first, then I'll do the simultaneous equations. I don't know specifically what Mariam wanted me to do with simultaneous equations, so I'll give a kind of a bit of an overview, and then we'll go through a few examples and we'll look at some typical sort of simultaneous equation questions. Wonderful, right, good. First off then, it was David who was asking for some help with the SAT stuff. First thing I'll say is it's really important that you work hard and that you do as well as you possibly can in your SATs, but it's also really, really important to bear in mind that it's not the be-all and end-all. It's not the end of the world if you do disastrously, which I'm sure you won't, but if you don't do as well as you had hoped, the world is not going to end. Nobody in 5 years' time is going to be asking you what mark you got on your SATs paper. So I'd try and keep it in perspective. Obviously work as hard as you can, do as well as you can, and take pride in your, in that hard work and the effort, and hopefully in the good result you get at the end of it. But don't be too hard on yourself, and, try and keep it in perspective. So that's the first thing. The second thing, and the final thing really, and I did mention this briefly on YouTube, but in terms of if you find it stressful, if you find going into exams stressful, if you're finding the whole process of doing a SATS exam, if you're beginning to get a bit anxious about that, the thing I think that helps the best with that and helps prepare you the best for a SATS exam, or any exam really, is to know exactly what you're up against. And the key to that is to have done lots of practice of SATS exams, okay, or lots of practice of GCSE papers. That way, when you come to actually sit the exam, what you'll find when you've gone through quite a few of them, and there are lots available online, some of them you have to give them your email and register your email, but there are lots of free SATS papers available, same for GCSE as well. But what you find when you've gone through quite a few of them is that they're pretty much the same year after year. You won't find many surprises at all. So really become familiar with what to expect. That has 2 benefits. Firstly, it means you'll know exactly what to practice. You know that in that SATS paper there's probably going to be a question, for example, where they ask you to find a fraction of an amount. So find 5/6 of 30 or something like that, right? But there's going to be something like that. And once you've seen a few papers, you start to, right, they keep asking this question about how you can find a fraction of an amount. Or I've noticed there's a question on finding 27% of something, or, something like that. You'll see the same questions come up again and again and again, which A is really useful because you can practice those questions. And if you can't already do them, you can make a list of the ones that you're finding difficult and ask your teacher, or if you have a parent that can help, or a brother or sister, or somebody who's good at maths and is happy to help you, they can go through those difficult ones with you, and you can just kind of tick things off, and you'll be able to see I'm getting better and better the more of these that I practice. But also it gets you into a frame of mind where you're not going to this mysterious unknown when you go and sit down and do the exam. Okay, you know exactly what you're going to see, so there's going to be no surprises. You're going to sit down, you're going to, yeah, I know exactly what this exam looks like. I've seen loads of these and they look the same pretty much every year, so I know what I'm up against. I feel pretty relaxed actually. This is just the same as when I was sitting in my bedroom practicing lots of these SATS papers. Okay, so those are my two key bits of advice really. First off, keep it in perspective, and secondly, loads of past papers. And that advice is exactly the same for people preparing for GCSE exams as well. Obviously, most of your time at school is about learning new things and then practicing those things. But as you get close to the exam, I would shift and, right, I've kind of learned everything I need to learn. Now I'm just practicing and getting ready for an exam. Okay, towards the end of your time at school. Okay, that is that. Right, moving on. I hope that was useful. Second thing then was solving simultaneous equations. Now let's go to yeah, it works. This technology is not quite what it anyway, I always struggle a bit with it, but it seems to be working. So you can see these questions up above my head. So what I want to do with these simultaneous equations, first of all, I want to sort of talk about the main principle that underlies simultaneous equations and what a simultaneous equation is. Then I want to show you the sort of fundamentals of the key techniques, and then I go through some specific examples using those techniques, okay? So the first thing, the underlying principle of a simultaneous equation. Imagine if you just had this first statement here, okay? The one at the top, where it says that 2 adults and 1 child cost £26. Imagine this is a trip to the cinema or something like that, okay? So you've bought 2 adult tickets and 1 child ticket and it costs you £26. It would, if that was the only information you had, it would be impossible to say how much an adult ticket costs and how much a child ticket costs. You could make some guesses. You might say, well, I think an adult ticket costs £12. There are 2 adults, so that will be £24. That must mean that the child ticket costs £2. That would be one guess. But we've got no idea. We haven't got enough information. Maybe children go free. So maybe an adult ticket costs £13. So 2 adult tickets will be £26 and children get in free. We don't know. Maybe adults get in free. And children's tickets cost £26, right? The point is, if that's the only information you've got, it's not enough to be able to work out the cost of an adult ticket or a child ticket. But then when you introduce a bit more information, as we've got in that second line there, that 2 adult tickets and 2 children's tickets cost £32, then we can work things out, because that second statement, they have bought a very similar thing to the first group of people, but they've got this extra children's ticket. Okay, that's the only difference, isn't it? They've got 1 extra child's ticket, and it's cost them £32, which is £6 more than this other group. So they got 1 extra ticket, which was a child's ticket, and it cost them £6. Therefore, we can correctly surmise that 1 child costs, I tell you what, costs £6. Once we know that a child ticket costs £6, we can go back and we can work out what an adult ticket costs. And we could do that using either of those 2 statements. It's going to be easier to use the first one, I would say. So we got the 1 child ticket is £6. That means that these 2 adult tickets between them must cost £20. So each adult is going to cost £10. And so we just solved a simultaneous equation. Okay, when you had one of those statements, you didn't have enough information, but when you combine 2 of them together, you're able to use both of those statements in order to work out the value of each of those things. So 1 adult, I do apologise for my writing, by the way, it's never ever improved. 1 adult costs £10. Nice thing about simultaneous equations is that you can always check your work. So it worked in the first one. We said that 2 adult tickets, that's 2 lots of 10, that's £20. Add the £6 for the child ticket, yep, £26. But it should work in the second one. If it doesn't, we've gone wrong somewhere. So 2 adult tickets would be £20, 2 children's tickets would be £12. Add those together, it's £32. we can give ourselves a big tick because we got that correct. Okay, so that's the underlying principle. Right, let's look at some. I want to show you, before we get into some specific questions, I want to show you one of the key techniques that we use. And that is, where is it? Number 2 here. There we go. You can ignore, oh, look at that. That's clever. Right. So if I've got two statements like this, 5 add 7 is equal to 12 and 8 add 9 is equal to 17. What we could do, there's no real reason why we would do this, but just to show you that the principle works, we could add this whole lot together. So we could say, right, 12 add 17, that's 29. 7 add 9 is 16. 5 add 8 is 13. So 13 add 16 equals 29, right? In adding all of those statements together, it still makes sense, doesn't it? 13 add 16 is equal to 29, right? It still holds true, if you like. And so that's when we're adding them together. Let's make a note of that there, that we added. But we could subtract one statement from the other as well. And that's what we're going to do in the second one. So I could do 14 take away 5, which is 9. And then 6 take away 3 is 3. 8 take away 2 is 6. And we were adding those. So yeah, that statement still holds true. 6 add 3 is equal to 9. Now, I can't really think of why we would do this sort of when we're dealing with numbers and why we would do such a thing, but it's just to show that it does work, because this is exactly the principle that we use when we're solving simultaneous equations. We're going to add two whole lines together. Okay, so let's jump into that. Let's look at some specific examples. And if you're watching, hello people that are watching live, you can jump in and shout if you have any questions along the way. What do I want? Number three. That is this one. Okay, now we're into it. So this is the kind of question that you're going to get in a textbook, or that you might get in an exam when you're asked to solve a simultaneous equation. You can see it kind of looks similar to that first example that I did when we were talking about the cinema tickets and things like that. Now, in this first question, you can see I've got 2y at the top, and then I've just got 1y in that second statement. But what I have is the same number of x's. I've just got 1x here, and I've got 1x underneath. And that's what we're always looking for. We want one of our letters, we want to have the same number of them, okay? So we've got 1x and 1x. That is good. We're going to do, just like I did a second ago, we're going to subtract this second equation from the first one. And the reason we want to do that is because if I do x take away x, x take away x is 0. They've kind of cancelled each other out. So if you take away 1x from 1x, you're left with nothing. What that means is, well, let's do the whole lot. Okay, so 6 take away 2 is 4. 2y take away y, I've just got 1y. And then x take away x is 0. So I'm not going to write anything, and they just cancel each other out. So we now know that y is equal to 4. And if we know that y is equal to 4, we can go back, substitute that into our equation to work out what x must be equal to. We could go into either of these two equations. I would go with whichever one looks easier, and I think that's this second one. And we'll substitute that back in. So x add 4 is equal to 2. Seems a bit strange, doesn't it? Something add 4 and it gives me 2. All you've got to do is subtract 4 from both sides, and that will give me x. 2 take away 4 is equal to negative 2. Okay, so we had a negative, which often throws people, but the principles never change when we're solving these. So y is equal to 4 and x is equal to negative 2. We could go back and double check in that first equation that it works with that one as well. So negative 2 add 2 lots of 4. 2 lots of 4 is 8. So negative 2 add 8, it is equal to 6. So we've got a really nice way with these of checking whether you've got it correct or not. That one was correct. Let's give it a big tick. Okay, second one, same idea. We've got these two equations, and this time we've got different numbers of x's, okay? We call this the coefficients, the number of x's that you got, but we do have the same number of y's, okay? So these y's will be able to cancel each other out. So if I do 4y take away 4y, that gives me 0. So that's what we're going to do. We're going to subtract one equation from the other. Now, can you see, if I do 16 take away 24, that's going to give me a negative number, negative 8. And if I do 2x take away 3x, that's going to give me a negative as well. It will be negative x, which is fine. We could do that and we could solve it like that. Not a problem. But why not make our lives a little bit easier? And we're going to do it the other way around. We're going to do this second equation, take away the first equation. So I'm going to do that second equation, number 2, take away the first equation, number 1. Okay. I'm not going to rewrite it. I'm just going to kind of keep that in my head and hopefully I'll be okay. So 24 take away 16, we're doing it that way, is 8. 4y take away 4y is just 0. They cancel each other out. And then 3x take away 2x, I'm just left with 1x, which we just write like that. We don't bother writing 1, do we? It's just x. Okay, so x is equal to 8. Now we can go back and substitute into either of our two equations to work out what y was equal to. And again, just whichever one looks easier. So that first one looks easier to me, although there's not much in it really, is there? Let's substitute. I'll write that for you this time. So I'm going to substitute that x in. So I've got 2 lots of x, and we know that x is 8. So 2 times 8, add 4y. Oh, that's interesting. I hadn't worked out the answers to these before I started. 2 times 8, add 4y is equal to 16. Well, 2 times 8 is 16. 16 add 4y is equal to 16. To solve this, to get those y's on their own, we need to subtract 16 from both sides. That's 16 there. So we're just left with 4y is equal to 0. And if 4y is equal to 0, 4 lots of something is equal to 0, well, 1 lot of something is equal to 0 as well. So there you go. Y is equal to 0, x is equal to 8. We don't expect to get answers of 0, do we? But sometimes we do. That's fine. Doesn't mean you got it wrong if you end up with an answer of 0. But let's double check that it works with the second one. So we're saying that x is 8. So 3 lots of 8 is 24. 24 add 0 equals 24. Yeah, so it works with that second equation as well. So let's give ourselves a tick on that one too. Okay, that is the kind of key principle, that you've got your two equations. You've got your two equations, and sometimes you're going to add those two equations together and it will end up cancelling out the x's or cancelling out the y's or whatever letters. It's not always x's or y's, is it? All right, let's look at the second type of one that you're going to see. So that was, what do I want? Slide number 4, I think. I had a couple prepared here. So we've got 3x plus y is equal to 11. And then we've got 6x minus y is equal to minus 8. Now, crucial thing here is, we think of this as a negative y, okay? And if we were to do just like we did in the previous examples and subtract that second equation from the first equation, when you subtract a negative number, that has the effect of adding on, okay? So 2 take away negative 3, let's put that in brackets, is actually the same as adding 3. That's the same as doing 2 add 3, so that would give us 5. Okay, you need to know that. So a bit of negative number stuff. Let's get rid of that, because that's relevant to this question. There we go. So if we did y, take away negative y, that would be the same as adding y. So we would end up with 2y. And we would have x's and y's in the answer. Well, that would be no good because the whole point of what we do is to cancel out either x's or to cancel out y's, okay? Or a's or b's, you know, whatever the letter is. So what we do with these, when your sign is different, we've got the same number of y's, but the sign is different. One of them is positive y, one of them is negative. When that is the case, you're going to add those two together because positive y add negative y is 0. If you think, you know, negative 3 add positive 3 is just 0, right? And that's what we're doing here. Even though it's letters, that principle is exactly the same. So we're going to add these two equations together. So 11 add negative 8. Well, adding negative 8 is the same as subtracting 8. So that will be 3. 11 add negative 8 is 3. Y add this negative y is 0. And then 3x add 6x is 9x. If 9x is equal to 3, to find out one lot of x, we've got to divide by 9. So x will be equal to 3 divided by 9. Just going to write it as a fraction like that. 3/9, in other words, which will simplify to 1/3. Okay, so we've sort of jumped in a bit at the deep end with these, but because we've had negatives and now we've got an answer that is a fraction, but that's all right. That's how life is, isn't it? It's real life questions. You don't always get nice round whole positive numbers to deal with. So if x is 1/3, we're going to substitute that back into one of our original equations to work out what y is equal to. So let's do this one. So I'm going to do 3 times x, which is, we know is 1/3. So 3 times 1/3, add y is equal to 11. 3 times 1/3 is just 1, isn't it? If you've got 3/3 of a pizza, you've got one whole pizza. So 1 add y is equal to 11. So y must be 10, mustn't it? 1 add something makes 11, that must be 10. So y is 10. So x is 1/3 and y is 10. We can confirm that by checking with the second equation. 6 times 1/3 is 2. And 2 take away 10 is negative 8. So it works in that second one as well. Move my head that way a bit. Sorry. I did this last week. I forgot that I'm writing behind my head. Okay. I hope you can see that. I'll shift over this way a bit. There we go. Right. Let's do the second one. So, well, this is different again. We've got the number of A's that we've got is different. We've got 3A here and 5A there, but we do have the same number of B's, and they're both negative in this case. So, are we going to add these two together, or are we going to subtract? Well, we're going to subtract. The only time you add them together is when the signs are different, when one's positive and one's negative. So in this case, we're going to subtract them, okay? Because negative 2b, take away negative 2b, is actually 0. When you take away a negative, it's like adding, okay? So this happens all the time with simultaneous equations. You've got to be really good on your negative numbers, okay? So to get good at simultaneous equations, and in fact loads of other things in maths, you've got to be really solid on your negative numbers, all right? So have a practice of those if you aren't already. And do you know what? I'm going to do the same thing I did earlier. I'm just looking that if I do 57, take away 111, that's going to give me a negative. If I do 3a, take away 5a, that's going to be negative. Let's just make our lives a little bit easier and do them the other way around. So we're going to do that second equation, take away the first equation to keep our answer positive. So 111, take away 57. Oh, what is that? If we take away 7, that'll be 104. Take away 50, that'll be 54. And then 5a, take away 3a is 2a. So 2 lots of something is 54. 2a is 54. So a is going to be half of that, which is 27. Then we're going to substitute that back into one of our original equations. I'll go with the first one because it's got the least number of a's. So I've got 3 lots of 27, which is 81. Let's write that out. Let's write it all out properly. 3 times 27 minus 2b is equal to 57. So 3 times 27 is 81. 81 minus 2b is equal to 57. What's the easiest way? I think the easiest way to solve this is 81 take away something makes 55. What have I got to take away from 81 to make 55? Excuse me. If I move 6 places down the number line, that will take me to 75. And then I need to move another 20 places down. So if I take 26 from 81, that will give me 55. So this 2b must be 26. Okay, because 81 take away 26 gives me 55. And if 2 lots of something is 26, 1 lot of something must be 13. So A is 27, B is 13, and let's double check with the second equation that that is correct. So 5A, 5 lots of 27, 5 lots of 20 is 100, 5 lots of 7 is 35. So 135 take away, have I gone wrong here? 135 take away 26 isn't 111, is it? Did I? Oh, this is 2b is 24, isn't it? That's what I did. That is a perfect example of why it's worth doing that check at the end, because you can make mistakes. I'm a maths teacher and I got it wrong. So if you're just learning this or you're still just practicing this, the chance you might get some wrong as well. Okay, so do that check at the end. So 81, hang on a minute. 81 is 27 times 3. Is that definitely 81? 6, yes it is. 81 take away can anyone spot my deliberate mistake? Why did I write 55 there? There you go. We all make mistakes, don't we? So 81 take away 2b is 57, okay? 81 take away something is 57. If you take away 24 from 81, you get 57. So 2b is 24, 1b must therefore be 12. Let's double check that in the second equation. We're going to do 5a, which we said is 135. 135 take away 24 does make 111. Good. Oh, that was a relief. Go on, off you go. I need to finish. Right. Sorry about the interruption. That is really the key things that you need to know about solving simultaneous equations. They do get even more involved than that, but I have been rambling on for half an hour, which I think is probably long enough for anybody, to be honest with you. At some point I'm going to do a full-length video on these on the YouTube channel, but I've got quite a backlog at the moment, so it's going to be at least 6 weeks away. I hope that was useful to you in the meantime, and I'm very happy. Let me know either here on the Facebook page or on the YouTube channel if there are different types of simultaneous equation you would like me to look at, or if I didn't quite get onto the ones that you're struggling with, then I'm very happy to do those again next week. But I'm going to call it a day there on those. There we go, back to full screen. That's it. That is it from Maths Kitchen for this week. Don't forget, if this was useful, give my page a like. And if you haven't already checked out my YouTube page, it's called Maths Kitchen, YouTube /Maths Kitchen, or just search for Maths Kitchen on YouTube. You'll find it. There's links on my page as well, so you should be able to see that. Have a look at some of my videos there, and it's really, really helpful to me if you can subscribe to the channel or give the videos a like, or just show the channel a bit of love in some way or another. Share it with your friends or whatever. I will be back next Sunday, back to the usual time of 5 o'clock next Sunday. Let me know during the week if there's anything that you would like a hand with. And it doesn't have to be super complicated like simultaneous equations. It could be something very easy. You know, how to use a number line, for example. It could be, you might be a parent who wants a bit of help to sort of help your child with their maths. And, you know, I know things have changed the way stuff is taught. So if you, for example, number lines, you know, so do join in and ask me if that is you. I'll do my best to help. Otherwise, thank you very much for watching, and I shall see you next week.